Hi everyone, this is KubeVirt DRA Support Sync August 19th instance. I'm going to share the agenda link here in the chat. I do see some new participants, so I request folks to put their names in the attendees and um, also I would like to give a moment for new folks to introduce themselves. Jian, you want to go first?
Okay, yeah, I'm Chen from SK Telecom, and currently working on the DRA support for KubeVirt, and hopefully, we choose to come up with some uh, new enhancement for the KubeVirt in terms of the DRA. So we want to make some proposal for this through the meeting. Thank you.
Nice. Welcome to the call. And CJ Maxwell, do you want to go?
Yes, hello, I'm CJ Maxwell. I'm joining from AMD, and we're doing some shuffling right now. So just uh, as someone gets becomes assigned to KubeVirt, they'll be joining more regularly. Uh, but I just wanted to cover this meeting and just take notes just to see what was happening.
That's awesome. Welcome to the call. Yeah, I think we can get started. So the first item I have on the agenda is well, before we go to the specified agenda, I think um, Jian and I were discussing before the start of this call that he wanted to, go first. He might have to drop later in the call. So go ahead. We can discuss your topic first.
So yeah, thank you. So before I go to the slide directly, I just want to give some background on this web app. And actually, SKT runs a GPU VM with SRV networking on a large multi-node estate, where GPU and the PFVF P2P throughput depends on both device sharing a PCI root complex. And the constraint device plugin allocation, what we have so far in Kubernetes can't express it. So pairing is silent locked today. So with DRA GA in Kubernetes, and we also have some beta phase for the Kubernetes support on this DRA. So the DRA allocates and the Motus configures integration now merged in the Motus CNI and the DRA driver SRV Motus mode. So KubeVirt is the only component that cannot render that required pod sake uh, for today. So this web as an optional resource claim field to the Motus network. So Motus networks we have can be sourced from a DRA resource claim. So which can enabling the scheduler inference the GPU NIC pairing via the match attribute PCI route. So for the if so, can I share some of my slides to explain a bit details on our design?
Sure. So let me stop sharing and you can try to share. If not, I'll have to find a way to make you a host. So why don't you go ahead and try to share?
Can you see my screen?
Yes.
Cool. Okay. So can you see my screen now? Is
Yep.
it in the full screen, right?
Yes.
Cool. So yeah, so everyone, yeah, thanks for the slot for today. So I'd like to walk you through the web draft, what we are preparing and sourcing a Motus network device from a DRA resource claim. So one line pitch is a scheduler enforced GPU and NIC topology alignment for VMs without asking anyone to migrate their existing Motus SRV estate. So it is very, very small API change. And I want to just briefly go through the design what we have so far. So here's the entire proposal on one slide. And on the left-hand side, everything is the user sees. A Motus network get one new optional field, resource claim, and pointing at the claim name and the resource name from the VMI's resource claim list. So everything in the green box stays exactly as it is today. So Motus still runs the CNI with the nav config, and the VLAN and the MAC and trust, those network status is still written, and the Vert launcher still builds the host data from the network status. So at runtime, it is still a plain Motus network. The only thing that changes where the VF comes from. So instead of opaque extended resource derived from the NOT annotation, it is now a named request in the claim the user wrote. So, and that is the whole point. Once the VF lives in the claim, it can share that claim with the GPU and the match attribute on the PCI root becomes enforceable by the scheduler. So Blast reduces the Vert API and the Vert controller, and only. So we do not change anything on this Vert launcher and Vert handler at all. So quick recap on why we care this is on the left is a typical two socket worker node. If the GPU lands under one PCIe root and the VF under the other, peer-to-peer DMA has to cross the socket interconnects, and the throughputs just collapse. And nothing like prevent this today. Just using the, for example, use the device plugin. So the pairing is purely luck. So there are free VFs or maybe PFs sitting under the right root, but the allocator has no way to prefer them. So, and the badly paired VM still runs silently slow. So the right side shows why the scheduler can help. So with the device plugin, the not resource name annotation becomes an extended resource. So literally an integer. So no device identity, no topology, cross device constraints. So the sentence here, the VF and this GPU under one PCI root is literally it's inexpressible for today's design. So now there are two existing ways to bring DRA into this picture, and neither reaches the goal. So VAP 183 DRA network replaced the Motus flow entirely. So for an existing NOT estate, that is real CNI contract rewrite. So CNI device like info file and the Motus apply config and the network status annotation that tooling reads, and on top of that, SRV was explicitly scoped out the DRA network in July. So DRA extended resource go another way, and it's zero KubeVirt change. Motus keeps working, but the scheduler creates an implicit single request claim per device, and the DRA has no cross-claim constraint. So GPU in your claim and VF or maybe PF in the implicit claim cannot be constrained against each other. So you have to end up hand pinning the root complex in the device class cell selectors. And if a VF pool spans two roots, it's mispaired silently. So what we actually need is actually the GPU and the PF or the VF has two requests in one user authored claim. And while Motus keeps configuring, that combination is exactly what this web has. So the interesting part is that the ecosystem already solved the node side of the problem of this. So Motus CNI merged its DRA integration in July with the PR 1492. It reads the path allocation claim, maps each device to its NOT via the resource name device attribute, and then run the CNI exactly as it always has. And the DRA driver SRV which has been open sourced through the network plumbing working group, ships the Motus mode that prepares the VF and the VF file binding and CTI injection. The device info file and the deliverable leaves a CNI invocation on the motor side. It also published attributes that make the mapping work. So the DRA allocation, the Motus configures is a working path shape now for now today. But this is only limited to the plain path. A plain path can carry the claim and the Motus annotation right now. The only component that can't produce this shape is a KubeVirt, because the virt controller still insists on injecting the extended resource. So this web is a control plane only change to render that already supported path shape and nothing more. And this is the single most important design decision where the field lies. So we nest
So,
it inside the, okay.
Can you go to the previous slide? I have a quick question there.
Okay.
So, in this slide, you mentioned that the DRA driver SRIOV ships in Maltus mode. Why is it why is it a requirement that you have to use the Maltus CNI and you can't use the SRIOV driver in Maltus mode for this?
Actually, for plain path, we can use the Motus mode for the DRA driver SRV. We can use that, but we cannot use that for KubeVirt.
I see.
For plain path, it's already working smoothly. And so we want to add that support for KubeVirt as well, because we are currently running VM on top of a Kubernetes. Yeah.
So Eddie, you can correct me if I'm wrong, but my understanding was that there was some work on the SRIOV driver to make it work with a KubeVirt VM. Does that not include Maltus?
Yeah,
Because
it's not Motus. Yeah,
Oh,
the
I see.
VF. Yeah, so VF itself is working. So there's a like a feature gate called the network device with DRA, but that doesn't support Motus.
And is there a reason why we cannot add support there?
For that feature gate or
Yeah,
what?
for that.
I will explain that in a following slide. Yeah.
Okay, sorry to jump
Yeah.
the gun. Go ahead.
Okay. So this is the most important design decision that we have to make for today. So we nest this it inside the Motus network rather than adding a sibling to the network source union. So that means for every consumer in the code base, its DRA network stays false. It's always false. And this is still the plain Motus network by construction. So everything on the right is the preserved without the touching it. And the single source admission rules and the annotation, like generation, the interface mapping and status pipeline, the word trash Motus path, like host that builder, and crucially, the two host that builder stay mutually exclusive. So duplicate host step are impossible by construction. That we did consider sibling the shape and reject it, and it flips is DRA network to this flag to be true. So which forces an exclusivity audit across every consumer. So launcher build and the status naming and the hot plug here, and it breaks the union one member CRD contract. Yeah. So what actually changes the two components? This slide really is that the whole for implementation details. The word controller does two things for a claim-backed Motus network. The one is it does not inject the extended resource anymore. The claim allocates the VF now, and then requesting both would the double book the device or leave the pod unschedulable if no device plugin exists. And then the NOT is still fetched just an early existent like a check. And two, it's add the claim and the request pair to the compute containers resource claim. And that entry is what makes kubely apply the request the CDI device and the VFIO nodes to the container. And the virtual API has 5 admission rules. And those are for the details, the rules that can be added. And for sharing a claim is fine, but the double booking the one request is rejected. And the existing rule against the mixing with the pure DRA network stays. And with the gate off or the field absent, literally nothing really changed. Fully it is fully backward compatible. So yeah, this is so here's the whole thing end to end. The user write one claim template, the GPU request and the VF or maybe PF request, and match attribute on the PCI root, and reference it from the VMI. Then word controller render the path, and Moto's annotation is exactly as today. Both claim like requests on the compute container and no extended resource here. And the step 3 is one that matters. The scheduler allocates the claim and the GPU and VF or PF are forced onto the same PCI root. And if that is not satisfiable, the path stays pending with the clear events. So from there, it is all stop the machinery, the driver prepare the device and node prepare resource, Motos map the claim like device on the NAT and runs the CNI with the VLAN, MAC config, and so on. So step 4 through 6 needed 0 change. So the echo system already knew how, and so the KubeVirt just had to like render the right path. So this is full user surface. So straight from the web API example, on the left is the claim template, 2 requests. The GPU request against the GPU like device class, and the VF request selected by the cell expression on the resource name attribute, matching the same value the NOT carries in it annotation. And at the bottom, the constraint that ties the 2 requests to one PCI root, as noted here. On the right, the VMI. The claim is referenced once the resource claim. The GPU consumed the GPU request through the existing web 10 field, completely unchanged. And the Motos network keeps its network name pointing at the existing node plus the new resource claim block pointing at the VF request. The rendered path ends up with the both claim entries on the compute container and the same Motos annotation as before. So no extended resource. And the 5 admission rules from the previous slide guard all of it. And I want to be explicit about the positioning because SRV, the DRA network has some history in KubeVirt. So this is sort of like complementary to Web 183, not competing. And the 183 defines the DRA network, the driver or binding plugin, delivers a full configured device. And the Motos is out of the picture for that interface. So it deliberately scoped SRV out in July, citing the competing industry approaches, what I read through the repo. So we don't reopen that question. Here, the network is just Motos network. DRA role is a strictly allocation. Configuration still stays with the Motos and the NAT. And the approach we composed within is one, the network plumbing working group has already merged. So 2 web shares the claim request type and the tuple uniqueness validation. They stay mutually exclusive within one VMI and separate the feature gate, keep their graduation independent. So whether to fold them together later is like a kind of open question we can decide at that time. Okay, so this is a quick status. So Motors merged is a DRA integration in early July, and we finished the design and the proof of concept against the 1.9, like in KubeVirt 1.9 in mid-August. So about five, like around like three or four small PRs. So all control plane like changes. The launcher and the handler is totally unchanged. And this week we validated the whole thing and end-to-end on a physical test bed, a shared GPU plus PF plane under the match attribute both the device on the one PCI root and not configured by the motor. So this is not it's not just a paper design. It's a really working like a piece of work. So the ask today is alpha scope for 1.10, the field, the admission, the renderer behind the gate with the unit test metric and no entry end-to-end lane, which matches the current DRA alpha the model. So manual validation is fully documented. So scalability-wise, it is boring in good sense. So no new watches or controller. Automation is all of network. So and the rollback follows the standard DRA alpha policy. So this is sort of like a real like a live demo. And since we are running out of time, just want to briefly show some running demos on this. So this is our test bed. And here we have two GPU node, and each of node is it's a HGX B200. So there are 8 B200 GPUs equipped in each node, and we are running the KubeVirt on top of that, just running some VMs there. So we already spawned one VM called the G2PIX test. So if you go to the like the, the console, here we already set up some device classes here. So as you can see, we have 8 GPU fabrics. No, it's just GPU devices. Oh, no. So sorry, it's a GPU fabric. Yeah, it's all GPU fabric. So it is an InfiniBand network. And for resource slice, we have already have a three types of SRLV or maybe InfiniBand resource slice and the three GPU resource slice has been uh, discovered. And if you just query the PCI root details, as you can see, some of the device already exposed correctly their PCI root value. So once we start to schedule the VM, then those PCI root value can be used to be matched so that we can always can schedule the right devices on for the VM. And for since spawning a VM will take some time, so we already spawned a VM called the G2PIX test. And once you go into the YAML, we already have two claims. So we have two claims. One is so this claim is looks a bit long, but this claim is try to stitching the two different devices into one, like a resource claim template, like that. Yeah. So two claim templates, and we have the resource claim, and the two claim what I shown in the YAML is has already been running like this. And if you query the resource claim and oh sorry. So so if you query the resource claim, we can see two resource claim. One is GPU and another is NIC, and its PCI root is identical because this is not. I think this is not PCI root. The PCI root it's a 1.7, it's a 1.8. The root of the PCI is the same for the two resources. Like as you can see, one is 17, the PCI root is a 14. And for another SRV PF, the PCI root is the PCI address is 18 and the PCI root is 14. So which means that the claim stitching the two like the device resources at the same time for this. So it's a working demo, and with this we can support the Motus network without changing anything on that hand side. But we need some change on the KubeVirt side. So we already prepared some draft web. So we have not yet been published it, but we are working on that. So we want to get some feedback from through this session. So if we get enough feedback, we want to publish it to the KubeVirt enhancement repo and so on. So any comments or any feedbacks or questions?
Amazing demo. Thanks for sharing. I see folks from SIG Network here. Does anyone have questions slash feedback on this?
How many folks do you see, Ale?
Yeah, it was for you, Harry.
Uh, Generalizing, yes. Yeah, thank you for presenting. It was very clear. I mean, I will ask in general, I don't expect an answer here. Is first of all, is this SIG network or SIG or this DRA discussion? Because most of the topics that I think were covered were not really DRA specific. At least the DRA part I think is already solved. Like whatever exists now, I think it's sufficient for what you need. So the only addition here is that network will solve this, like to add this option. That's one, and the second one is maybe it's a bit related. I was part of the discussion that were discussing the DRA networking and how it will work, especially with SRV, which was dropped for now. It was deferred for later. And it was mentioned that maybe CNI or should still be used and so on. But from that discussion, my impression was that the Multus, like the mix between Multus and DRA, is just an intermediate solution until DRA fully supports all the missing parts that Multus had. Something like that. This is my impression that I got, and I want to understand if this is really the case. And if this is the case, then introducing an API under the VM in the VM spec, it's a bit a challenge. It's like saying I'm going to introduce something for a year or two or something until the array is stable and it will give me the same solution. So that's my initial feedback.
So, Eddie, I think I also had heard similar discussions where folks were trying to see if Malta's CNI is needed at all in the DRA path, or we can have one driver do everything. I am familiar with those discussions, but I to me that seems like an implementation detail on the driver side, right? We can still open the web. I mean, the web issue would be very specific. How do you make Malta's um, network work with DRA, right? And whether
Mm-hmm.
the solution happens through the network Maltus network field that was presented here, or it
Mm-hmm.
happens through a separate spec field. We can go to the group that is discussing this and figure it out,
Okay.
short term, medium term, and long term. But
Mm-hmm.
regardless of that discussion, I urge you to um, file the web issue as soon as you can, as soon as
Mm-hmm.
you are comfortable, because we are in the 110 cycle and we will need early heads up for the reviewers to come in and help out on this. So let's file the issue unless there is anyone who has bigger concerns than already discussed. Let's go ahead and file this issue, and then we can maybe in as a follow-up go to the DRA driver folks on the networking side and figure out like what is the roadmap
Mm-hmm.
for Malta's support.
So I'm just saying that please, I mean, what I'm suggesting, you could file a web anyway. I don't. There is a chance that because there are so many webs at the moment for 110, it's a bit. I think it's a bit too late, but I'm not sure. Maybe if it's
Okay.
something simple enough, it will somehow go on. But
Oh,
my I will consider just saying you don't have to if you are able to solve it uh, without touching anything inside KubeVirt from outside, then this is also an option. Like you should, I think, an alternative for that should be considered just so you will have a backup and a way to progress. For example, if you can describe in your DRA claim a reference to the NAD, and then someone will do all of this work as a subsequent of that thing, then that is also an option. You could use the integration with the binding plugin and see if that can help you, because the binding plugin also can create NAD. It can also reference NADs. So you should think about also about options not to involve KubeVirt in it, because there is the main thing that I find challenging here is this like the real end goal of how DRA should work, like uh, and that's it. By the way, the same question I could ask. You have like will you put DRA references under Multus, or you should put Multus reference under the DRA? So it's like a good also open question here. Anyway, I think it's related to your vision of how DRA and how it will work as in the future. Will it deprecate Multus in the end or not, and stuff like that.
okay. Thank you all the feedbacks. So yeah, definitely. I will prepare another web and publish it to the repo and get the feedback from the community. And yeah, really appreciate all the feedbacks and comments.
Awesome. uh, there is one more thing I wanted to suggest, which is there is a web discussion call in the KubeVirt calendar.
Mm-hmm.
Once you have the web and the design doc, it would be good to go and represent it there. You'll get more direct feedback on what the reviewer bandwidth is and things like that. I can help you navigate that. Feel free to reach out on Slack about that.
Okay, cool. Thanks.
Okay, that's awesome. I think we are very much over time for today's call. Uh, we can. So the only other big item I had for today was to discuss um, the VM scoped persistent resource claims. I think Eddie, you had some review comments Do you want to take an attempt to discuss those here, or we can discuss that async?
Which one? Sorry.
Uh, oh, I realize I'm not sharing. Give me 1 second. It's this.
Oh, that one is yes, an interesting one.
Yeah. The biggest discussion topic I think we had in mind was around whether this API is generic for pod and VMs, or this is only needed in the case of VM. So my understanding is that we have not come across a use case where this is required in the pod case yet. This
Yeah,
is very much a VM requirement as of now.
yeah, but it's like this is I mean, what you just said, it's very accurate. But in general, KubeVirt, like the idea of KubeVirt, its core is that it will use as much as possible Kubernetes patterns or solutions over reinventing it itself. And the problem that I'm seeing here, first of all, the scenario of saying I need a claim and that claim needs to exist outside of context of a pod lifecycle, right? It makes sense. Like I have like I don't know a device that has state, and I want pods to die and be recreated again, and I want that thing to still exist, right? I can make sense to have this, and this is the case here. The the question is, does it make sense to solve it in a generic way so it will be used by KubeVirt, or KubeVirt needs to solve it itself? I don't person sorry. I do not. I mean, it was reference about the PVC, right? The existing
Yeah.
uh,
Issue.
yeah, yes, not issue. It's like the existing configuration allows to define things at the VM in parallel to having things defined in the VMI, like under the VM in the template spec. I don't like that one. That sounds like a duplication of feels like a duplicate, and maybe there is no other option, but feels too very odd to me. That now that we know more about APIs and stuff, to repeat this again, I am not in that happy to do. So if there is an option to do it really as a some independent controller that does it, or with its own admission things, then I would like that solution better if it's feasible. I hope you understand what I mean. I mean, someone creates the resource, and then COVID can use it, but it's somehow independent from each other.
Yeah, I understand what you're saying. I think what is needed here is an ability to express that for this VM, this particular claim should persist, and others are normal resource claim, it can be deleted and recreated. I think that is the reason why we have to duplicate the entire thing.
Yeah,
um
and the question will be, and this I think it was asked here, is this something that we need it to be generic, or is it we know exactly in which cases? For example, I'm looking at the spec now of a VM, and I will know that now I need it persisted per VM and it's not per. I hope I am. For example, if it uses VTPM or it uses something specific, then I'll have a policy that says, okay, this means that I want it to persist at the VM level and not the VMI level. something like that. I mean, is it possible if it makes sense to do it like that and not per VM specific?
Yeah, I see. I hear you. Okay. I think John is not here, but I can sync with him uh offline to find a way to explore if this is possible. My thought process right now is that this is not possible, but we will try to come up with something and see if we can express this independently of adding duplication in VMI spec. I think there was an update. John represented this reference counter thing on the resource claim status, and it was approved uh, by the Kubernetes folks. It is a good API to use for this use case. So at least on the implementation side, we are following what Kubernetes is recommending for managing the life cycle. So I think the only remaining questions are on the API and the user experience of this. Yeah, I think we can stop here. I will find a way to, we'll try to answer if this is the best API we can come up with, or are there any alternatives here? Okay. So that's all I had for today. Thank you, everyone. It was a very productive meeting. And see you guys in 2 weeks. Thanks. Bye.
Bye bye.
Thank you. Bye.